So give it a few seconds. Okay. Welcome at long last to the first session of a new module. So, yes, apologies once again for the delayed start. We can blame a combination of me and British Railways. But yes, here we are now. So welcome to the start. Welcome to session one of a new module we're calling Core Developer Skills. So this will be the next probably 4 weeks or so. We're not actually going to teach you any new C++, despite being C++ London Uni. For the next few weeks, we're going to be focusing on other skills that are going to be useful to you, hopefully, as a developer. There's not much that we're going to do that's C++ specific. You will be sort of working on a couple of sort of baby projects, but there's no, as I say, not really any new C++ that we're going to teach you. But hopefully it'll be a fun and interesting module anyway. So it's going to be a bit of a new experience for us. Yes, hopefully you'll get something out of it. Before we begin, because I can see a couple of new faces, I always have this slide. Yes, by the way, you've gone back to the really boring black on white, not very interesting slides by me. I'm afraid you don't get the fantastic ones Ollie did last time for the last module. But anyway, yes, so we always have this slide on feedback. So we like to hear from you. We like to know what we're doing well, what we're doing not so well. Hopefully more of the former. But the best way to get in touch with us, or to, if you want to discuss things, if you want to ask questions, that sort of thing, is to go on Slack. We have, there's a CPP Lang Slack channel for discussing the C++ language in general. And we have our own room in there, this hash CPP London Uni. So it's technically something you need an invitation for. It's a really exclusive club. So you just go to that URL, pop in your email address. It'll send you a link that you just click, and you can log in, and then you can find the CPP London Uni room in there, and you can talk to us. So yes, I've already mentioned this module is Core Developer Skills. There's going to be no new C++ for you today for the next few weeks. So we're going to be talking about Git, we're going to be talking about GitHub, we're going to be talking about CMake, which is the most common build system that's used for C++, for those who don't know. We're going to be talking about continuous integration testing, so things like Travis and Jenkins is the one, yes. We're going to look at using the debugger, probably via C-line. How you can use that to investigate crashes in your programs and things like that. And then we're also going to have what will probably be quite a fun session on common interview questions, where we might put one or two of you through the mill and ask you some tricky questions. Does that sound good? Yeah, excellent. All right. So this week we're going to be talking about Git. Who's used Git? Quite a few of you. Hopefully you will still learn something today. Hopefully you will come out, going, oh yeah, this stuff's easy. I thought it was tricky. So we're going to go through Git. We're going to make sure everyone's set up with Git. We're going to go through how you can use Git on the command line, what the commands are, common commands, how to use it, that sort of thing. And today's a very sort of interactive session. I want you to follow along with the commands when they're on the screen. Tell you what you want. Tell you what I want you to do. And hopefully it'll be interesting. But for those of you who are here last week, it was the end of a module, the end of an era, the end of a module. Ollie spent a few weeks talking about object-oriented programming in C++. And as is traditional, when we reach the end of the module, we had a little quiz for you. So hopefully everyone who did that got their results emailed to them. Did anybody not? No? Everybody did? Excellent. OK, so I think it's worth just briefly going over the answers, because there were some questions in there that there were some common mistakes. So I think it's probably worth just going over the solutions to that for a few minutes, just so people can see where they didn't quite get things right. Blow that up a little bit so everyone can see it. Oh, too much. There we are. Okay, so email address, first name, last name. I think everyone got those questions right. Well done if you were called Michael. You won. That was the most common answer. So true or false? In C++, classes may inherit from other classes, but structs may not. Is this true or is this false? This is false. Everybody knew this was false. Structs and classes are basically exactly the same thing in C++. They just differ slightly in their defaults. This was a trick question to weed out any C# programmers in the room. Okay, what's the correct term for a member function whose behavior may be overridden in a derived class? Everybody? It's a virtual function, yes. It's not any of the others which I just invented. Okay, which of the following is not a kind of inheritance in C++? Again, I think, so everyone got the first two questions right. Pleased to report. I think almost everybody got this question right as well. So public, private, and protected are the three sort of ones you might think of. There's also something in C++ called virtual inheritance that Ollie sort of touched on briefly. Sorry. It's used for resolving diamond inheritance problems. It's something you sort of reach for rarely, but it is in there. It is in the language. There's no such thing as partial inheritance. That was the red herring. I just made that up. Okay. Select every statement that is true. The private keyword signifies things that are not accessible outside of the class itself. True. The protected keyword signifies things that are not accessible to derived classes. False. Yes. The public keyword signifies things that are accessible to all. True. This is going well so far. The protected keyword signifies things that are only accessible to itself and derived classes. Right, that is the meaning of protected. Right, it's protected from the outside world, but you and your derived classes can still access any members that are protected. Go to the bottom one first. The friend keyword can be used to allow a function to access a class's internal members. That one is true. That one is true. That's in fact the purpose of the friend keyword. Friend keyword said that this function or this class is my friend and it can access things that are private to my class definition.
That statement's false now, that's not spot on.
Have I got a spelling mistake in there?
Friend keyword can use.
Oh, sorry. Yes, there is a missing word in there. I do apologise. Nobody else picked that up, so yeah. Can we spot the teacher in the room? All right. So the one that was a little bit misleading in here was the what's that? Option 5. The friend keyword can be used to allow two classes to access each other's internal members. The friend keyword allows one-way access. If I declare that this class is my friend, then that class can access things in my definition. It doesn't give me access to another class's private members. If you friend it both ways round, yes, it's a little tricky to do. You have to use forward definitions. But if you friend both ways round, it's possible. But by itself, it only works one way. Okay, same deal again. Select every statement that is true. The virtual keyword can be applied to both member functions and member fields, member variables. Is that true or is that false? Sorry?
False.
It's 50-50, right? But you're absolutely right. We can have virtual member functions. There are no such thing as virtual fields. We don't have properties in C++. Right, you can't override properties or anything like that. You have to write your own accessor functions and make those virtual. All right, so the virtual keyword allows for a function to be overridden in a derived class. True, that's exactly what the virtual keyword does. The override keyword must be used to override a virtual function declared in a base class. No, it'd be nice if that was true, but it's, you know, for historical reasons, it's not. So the override keyword is optional, but you should use it, of course. And the last one, the override keyword, is a compile time safety check to ensure that a function matches an existing virtual one.
Can you set your compiler so that it picks it up, forces you to do it?
I don't know off the top of my head. I know that if you, sorry? Oh yes, can you are there compiler flags that will warn you if you don't say override? I don't know.
I do, yes.
Oh yes.
It's generally turned on my default Clang. Modern versions of Clang and GCC will both go, you didn't override on this, you probably should.
Yeah, I know there's a warning if you write override sometimes and not all the time. Yeah. Yeah, the trouble is then if you have old code bases, pre-C++11 code bases that can't use override, then you get lots of sort of false positives. So they don't enable those warnings by default. Okay, one more time, every statement that's true. A class marked as final prevents any further inheritance. True. That's what final does. A class cannot be marked as final. False. A class absolutely can be marked as final. All member functions can be marked as final to prevent further overriding. Sorry? Can the constructor be marked as... No, the constructor cannot be marked as final. No. Ordinary member functions can be marked as... Or I should say virtual member functions can be marked as final. Member functions must be virtual or overriding a virtual in order to be final, which prevents further overriding. I think I just said that. Yes. It's possible to name a variable as final. For example, int final equals 0. It's in fact a funny thing. It's final because it was added to the language much later and because it's only used in very specific places in class definitions. It's actually what they call a contextual keyword. You can use it as the name of a variable like int final equals 0. You can even use it as the name of a class, which is weird. So you can have class final final. And then having done that, you can name a variable final.
So you can have a class final with a variable final in it?
No, because that would be a constructor, right? But you can have a variable of type class final that is named final, because C++ is weird.
I can't have a class called final.
Sorry? You can have a class called final, yeah.
In that class, I can't have a...
You can't have a member called final, no.
Even the letters are not the same one. The name of the class, first letter is capital, and the variable inside the class are just not capital letters.
So the point was commonly people will use a capital letter for the first letter of a class. That's a very common coding convention, but it's not used universally and it's not enforced by the language in any way. If you do use that coding convention, then of course you could have your class with a capital F and your member variable with a lowercase f, and that wouldn't be a problem.
The point here was that you could use that contextual language keyword.
Yes. The point here is that the word final is not reserved except in very, very specific places. That's not what final does in C++. Final says if you mark a virtual function as final, that means that nobody can override that in any derived classes. And you can mark an entire class as final, in which case none of the virtual functions can be overridden. Sorry? It's mostly used for optimization because it allows the compiler to sort of more aggressively optimize things. If it knows, it can do devirtualization more effectively if it knows there will never be a more derived version of this function. So yes, this, what's that, 1, 2, 3, 4, 5, this fifth one, it is absolutely possible to name a variable final. It's not a keyword, it's a contextual keyword. So it's only a keyword in certain positions. So int final equals 0 like that is absolutely okay, which means the last one is false. Okay, so people mostly did pretty well in these first few. Things get more interesting now. So here I've given you an I-person interface. You know, we don't have, unlike Java and C#, we don't have an interface keyword, but we have abstract classes that only contain pure virtual functions that fulfill the same role. So I've given you a bit of code here, and there's 1 or 2 little problems with this code. So I wanted you to list 5. So I think there is almost 1 mistake per line in this. Other than the comments, they're about the only bit that that would actually work. Okay, so we'll begin at the beginning. What's wrong with this line? Sorry? There we are. Yes, what's wrong with this first line here? Abstract class I-person. The word abstract, indeed, is not a keyword in C++. You cannot declare something to be an abstract class. Okay, that's the problem with word 1. What's the problem with word 2?
The line is virtual at the front, right?
No, we're still talking about this line, abstract class I-person.
Oh.
So the problem here is that because I've declared it as a class, everything inside it is private. So nobody is going to be able to call this nice getName function that I've defined. So there are 2 ways around that. Either I could change the word class to the word struct, or I could pop the word public, just at the top of the class there. So either one would be fine. But yes. Pop to the next line now. Const standard string reference getName const equals 0. What's wrong with this? Oh, sorry, yes.
Is it equal to 0, then I'll have to use the virtual keyword as well.
Absolutely. So the problem, yes, the problem with the second line is you need to insert the word virtual in there. We've tried to say that this is a pure virtual function without saying it's a virtual function. Right, so we need to say virtual const standard string ref getName const equals 0. Okay, any more problems with the I-person? Another hand, same hand, yes.
Yeah, you need to close it with a semicolon, the class definition.
That's correct. You need a semicolon after this closing brace, which I don't think anybody actually wrote. Oh yes, no, I missed that one. But yes, we also need a virtual destructor for our interface class. Okay, every time you have virtual functions, you need to make sure your class has a virtual destructor. So in this case, we'd say virtual tilde I-person, open close brackets, equals default would be fine. So the question is, would it work without putting the virtual destructor in? And it would compile, and you would get a problem if you tried to delete an instance of a derived class via a base class pointer. So if we had, say, a unique pointer to an I-person that actually held an instance of student, when we deleted, when that unique pointer went out of scope, when it tried to delete the I-person instance, it would only delete the I-person instance which holds no data, right? It wouldn't delete the student part of that. That would just get leaked. It would be very bad, right? But if we make the destructor virtual, then we get the usual the usual thing that happens with virtual functions, in which case it would dynamically find the real destructor for class student down here. It's still needed in C++ 17, yes. You still need a virtual destructor in C++ 17. So, yep, golden rule, whenever you have any virtual functions, add a virtual destructor. So quite a few, 3 lines of code and quite a few problems with it. The student class is equally problematic. That's not where final goes. In C++, we don't say final class student. We would say class student final. Okay, so those words are the wrong way around. So we'd have to say class student final. And then we have a colon I person. Can anybody tell me what's wrong with that? Public I person, yes. So classes default to private inheritance. Private inheritance is almost never what you, almost never what you want. Public inheritance is what you want. So again, 2 ways to fix that. Either we change class to struct, in which case we default to public inheritance, or we can say class student final colon public I person. And then we have public inheritance, which is what we want. Okay, we had a constructor. I can tell you there's nothing actually wrong with the constructor, that's fine. Some people tried to suggest that this thing of using the word name twice was not going to work. That actually works just fine. So this initializer list of name brackets name looks a bit funny, but it actually works just fine. The first name, oh, it's a bit sensitive. Anyway, the first name in the initializer list refers to our member variable, and the one in brackets refers to the constructor argument. Now, this isn't necessarily good practice.
I just wanted to point out as well that the override will work, even though it's private. Well, it's not virtual, but it's pretending that if you fixed iPerson, except for making it public, you fixed everything in iPerson, the left it private, so it's virtual and private. The override would still work.
Yes. Okay, you can override functions that are private in your base class, which is a really strange thing in C++, but it is legal. But in this case, that won't actually work for reasons I'll get onto in a second. But yeah, there's nothing fundamentally wrong with the constructor. It's not great practice to give your constructor argument names, to give the constructor arguments the same names as member variables, because, as I say, it looks a bit confusing, it looks a bit weird. And if we had a body for this constructor, then it wouldn't be very clear whether name referred to a member variable or a constructor argument. So it's not good practice, but it works just fine. There's nothing, it won't give you any compiler errors or anything like that. Okay, so this next line, we're declaring a member function which overrides our base class function. Or does it? The return type is different, yep. Okay, so the interface function, well, for a start, it's not virtual, but pretend it was, right? The return types are different. One is returning a reference to a string. The other one is returning a reference to a const string. Well, if I knew where it was, Tom, I would. There's another problem with this line. There we are. There's another problem with this line. Const missing, yes, absolutely. In fact, there are 2 consts missing. There's one const missing from the return type. We need to put another const at the end there. Remember, we can overload member functions in C++ on their constness, right? So getName and getNameConst are 2 different member functions as far as C++ is concerned. So if we tried to write this, even if we made it virtual in the base class, and even if we fixed the return type, we would still get an error. Because this override is not actually overriding anything. It's a different member function. And finally, most people pointed out that name here, we would usually probably prefer it to be a private member. Okay, it's in the public section of our class.
It shouldn't be as well closer to the top, so it's recognized as a variable. Because if say, well, I don't know what name is.
Oh, right. So Tom's thing is that he's suggesting that name is declared too late in the class because we're using it in our constructor here, and we haven't yet declared it. Is that what you're? Yes. That's actually not a problem. The way C++ works, it sort of looks at your class definition, and only after it's looked at the class definition does it look at the actual definitions of your member functions, right? So by the time it actually processes the definition of this constructor, it knows all the members of the class. Okay, so this it would actually compile, or the constructor would compile with name down there. That's absolutely fine. In fact, it's very common to put your member variables, your private member variables, at the bottom of your class definition, right? Because when other people are looking at your code, generally what they care about is your class interface. And obviously your private member variables are not part of your class interface. So it's very common to tuck them away at the bottom. And that's why C++ works the way it does. Okay. So submit a corrected version of the iPerson interface and a corrected version of the student class. Well, I think I've mentioned the many things that were wrong with those two. I think I counted 10 or 11. Okay. Now, mea culpa, I made a mistake in this question. I made a mistake because to try and get, I wrote it, and then to try and get consistency with the previous question, I changed the name of class animal to class I animal, and then I forgot to change it in this void feed function. So I made a mistake, and many people correctly pointed out that because this one here is named animal, and this one, the one up here is named I animal, this isn't going to compile. Which is absolutely correct. That was a mistake in the question. I apologize. What I was intending to show you was that by taking the interface class by value here in the feed function, we would get slicing. That is, we would lose all information about the derived class. Right? We'd need to take animal or I animal by reference. But in fact, as people pointed out, I made a spelling mistake, and so in fact, it wouldn't compile. If I had written I animal, then it would compile, but it would sort of silently do the right thing, do the wrong thing. So whether you said yes or whether you said no, whether you sort of recognized that I'd made a mistake and adapted for that, or whether you just took the code as it's written, basically, whether you answered yes or no to this, you got a point. So yes. Pays to guess, I suppose. Right, scoped enumeration. So the key to this is I wanted you to recognize what I meant by a scoped enumeration. That is, I wanted you to use the words enum class. So older C++ and C, in fact, have these unscoped enumerations. They're just declared with the word enum. And they're fine, but the problem is that all of your enum members sort of leak into the enclosing scope. So C++11 introduced these better enumerations. We call them scoped enumerations. Apologies, just one moment. Oops, don't do that. So yes, I wanted you to use an enum class containing, as I say, red, amber, and green. Most people, you know, got at least one point for that. And then this was a little tricky. I wanted you to show you that you knew how to use enums, basically. So the ideal answer to this, and at least one person did it, was I wanted you to use a switch statement. is the easiest way to do it. So you have a switch and you say, okay, if my traffic light is red, then the next state we're going to return red and amber. And if we have red and amber, we're going to return green. If we have green, we're going to return amber. And if we have amber, we're going to return red. Okay, so then you have an exhaustive switch statement, covers every member of our enumeration. So that's what I wanted. Yes, sorry.
I remember that I thought at this point that the individual members of the enum that they get converted under the hood to integer values, and that I could make use of that.
Yes, so there is another way to do it. So, like I said, the under the hood, an enumeration, the members get converted to ints or to some integer type, right? So these are kind of names for numbered constants, right? So you might have red is equal to 0, and amber is equal to 1, and red and amber is equal to 2, and green is equal to 3.
That's true no matter whether it's scoped or
That is true. Yes, that's true no matter whether it's a scoped enumeration or an unscoped enumeration. You can set that explicitly, so you could say that I want red to be 99, and I want amber to be 2002, and I want red and amber to be 3, and green to be -2, if you want to. If those numbers are meaningful.
So return plus TL doesn't.
Yeah, however, unlike in C, there is no automatic conversion from an enumerator to an int, right? So you could write this by giving you could write this function in such a way that you give meaningful numbers to the constants and then do some clever modular arithmetic to move through the sequence. That'd be a valid way of doing so, but in C++ and with scoped enumerations, you'd have to insert firstly a cast from type traffic light to an int, and then in order to and then do your modular arithmetic on ints. And then, because we want the function to return type traffic light, you'd have to cast the result back again. So it's possible to do it that way. Personally, I consider a switch statement preferable. It's entirely likely that a switch statement is going to give you better code as well.
better, you mean more efficient?
Yes. Yeah. But in principle, if you had correctly done it with using additions, then I mark that correct. But actually, nobody wrote a correct implementation using it. Yes.
In real world applications, do you use in that example, like the switch default section, do you really use that in sometimes maybe not the red and amber or green statement will be passed to this function, so the default will come up.
Okay, so the question is when you're writing functions like this, or perhaps not exactly in this, not this exact example, but do you use the default case in switches? And yes, absolutely you do. So perhaps in this case, the traffic light might have an error state where all the lights are broken, right? And then if the next state from error would probably still be error. So that would be an appropriate case for a default, maybe. I mean, I'm stretching it a little bit, but definitely the default case comes up. And compilers these days are very good at warning you. If you don't use every case of an enum, it will say, hey, did you forget to put a default in here? Because otherwise bad things are going to happen. Okay, we're almost there now. Almost to the end. What's the purpose of the explicit keyword? Marks a member function that cannot be called from a derived class. No.
It's to do with the attempt to like coercion into the types that's being passed in.
Yes, it's to do with preventing convergence. So, first of all, it marks a member function that cannot be called from a derived class. This keyword is not the keyword for this is not explicit. Can anybody tell me what you should use if you want to prevent a member function being called from a derived class?
Private.
Private, absolutely. Make it private in your base class, and derived classes won't be able to call it. Okay, does it mark a member variable? Sorry, does it mark a variable which cannot be changed after it's been initialized? No. What's the word for that? Const, absolutely. Marks a function which cannot be accessed outside of the current file. That's not true either, but there is a word that does this. Does anybody know what it is? We haven't covered it, but maybe somebody knows. No, it's one of the many, many, many meanings of the word static. If you have a function declared outside of a class, a free function, and you write the word static in front of it, that means that that function cannot be called outside of the current file. It marks a constructor which does not allow implicit conversions. That's the baby, yes, that is the baby. That's what explicit does. You can also put it on conversion operators, but for the most part, you see it attached to constructors, single argument constructors in particular, to prevent implicit conversions. Finally, it marks a destructor which must be called explicitly in order to destroy an object. No, there is no keyword for this in C++ because it would be a really, really stupid thing to do. So fortunately, the language doesn't let you do that. Okay, I very generously gave 2 points for this. When writing a class to be thrown as an exception, which standard library base class should you eventually inherit from? Standard exception, std : exception, absolutely. The standard library itself provides various classes that inherit from exception. There's runtime error and logic error and out of range and a few others that I forget. But they all eventually inherit from standard exception, and so should you, because it provides this .what member function that gives you some text that tells you, hopefully, what went wrong. So write a class named non-zero which has a constructor taking a single int parameter. In the non-zero constructor, throw an appropriate exception if the constructor was passed an argument of 0. So most people had a really, really decent go of this. I don't think anybody got 100% right. The thing you had to do, so you could have picked any of the error types in the standard library. I wasn't really very picky about that. Let's go with logic error. So what you would do would, in the body of your constructor, you'd say, if arg == 0, throw std logic error. And then the constructor of your standard logic error, you might give a string saying you pass 0 to the constructor or something like that. So as I say, most people had a reasonable go at it. They threw standard strings and things like that, despite having answered the last one correctly, which was interesting. But yeah, as I say, most people sort of had a reasonable go at that.
How many people got the last one?
Got this 100% right. Oh, actually, we found this before. Actually, people are really startlingly accurate about knowing how they did. Nobody thought they did perfectly, and in fact, nobody got full marks. But everybody did reasonably well. I think there were 36 marks available, and I think most people were in the 20s. So that's pretty good, because I don't want anybody to get 100%. That means I made the test too easy, right? Or I'm a great teacher, yeah, maybe. That's what I should do, just make the test really easy to boost my ego, right? No, Ollie taught this one. I don't know. Yeah, anyway.
Yeah, my fault, basically.
Anyway, that was the test. As I said, most people did pretty well. In particular, the opening questions, the ones right up here. I think everybody got, somewhere close to 100. We had a few quite imaginative answers to this question. Most people managed to get at least 5 errors, or 4 or 5 errors. The corrected versions, people didn't do so well. A lot of people thought that abstract was a keyword. Almost nobody noticed the missing semicolon or the lack of the virtual destructor. Again, most people, I think, noticed that final was in the wrong place. Didn't notice the missing const there. So yeah, in general, I think people did pretty well, and it, shows you you all learned something from the last module, which is really nice, and it gives us some information for when we're planning to running that module again. So that was that. Any questions about that exam from those of you who questionnaire? Any questions about the questionnaire from those of you who did it? All right. Oh, one moment. Sorry. All right, let's talk about Git. Yeah, okay. We have no animations. What's Git? Let's talk about Git, because that's what we're supposed to be talking about today, even though we've only got an hour left. So yeah, Git's a distributed version control system. Just sounds exciting. It's a distributed version control system. And it was invented by Linus Torvalds, rather famous guy, because he fell out with the people who were running BitKeeper, which is a much older version control system that was used to manage the source code of the Linux kernel.
Just a slightly quick, it wasn't him that fell out per se.
No, not he personally. Other people were reverse engineering the BitKeeper protocol, which BitKeeper was proprietary software. People developing Linux didn't like the fact that this, flagship open source project was managed by proprietary software, so reverse engineered how BitKeeper worked. The BitKeeper people didn't like that. Anyway, the upshot of it all was that Linus went away for a few weeks, or knowing him, probably about 12 hours, and wrote this new version control system called Git. At the time, there was nothing, as far as I know anyway, there's nothing really quite like it. Most of the world was using Subversion, which was kind of awful. The only thing worse than Subversion was CVS. And they were pretty terrible. And then Git came along, and it was much better than everything. And there are a few other distributed control systems around at the time. There's Mercurial, which is still used a bit. Canonical, the Ubuntu people, had their own called Bazaar, which they bizarrely still use. But these days, overwhelmingly, almost everybody uses Git. Certainly, pretty much every open source project you will ever have heard of or ever used will use Git.
And more to the point, a lot of proprietary systems that aren't Git integrate into Git, such as Microsoft's Team
Foundation, so yes.
And Purple's as well.
Yes, yes. So more and more, Git has completely taken over the world of source control. And many big organizations, the ones who've got sort of 10-year-old, 20-year-old code bases, they might still use their own older systems, the ones they've been using for years. Perforce is very common. Microsoft Team, is it Team Foundation Server, I think? Is that what it is? Yeah. TFS.
Team Frustration Server.
Team Frustration Server. Yes, that's still got used a lot of people who are, in Windows shops. But as Ollie pointed out, even these now either implement a Git interface on the Git command line interface on top of them, or they interact in a friendly way with Git. Git has more or less taken over. So it's a distributed version control system. This means that in principle, there is no one central authority that controls the software. Everyone's copy, in principle, is equally authoritative. And independent, yes. This is in contrast to older version control systems, the one I mentioned, Subversion, CVS, where there was a master server. And this server hosted the authoritative version. And you went away and you wrote your changes, and you push these changes back to the authoritative server. That's, I keep saying in principle, not how Git works. Now, having said that, these days almost everybody's using GitHub, which actually sort of comes back very close to this model of having the one authoritative version, which is the version that's on GitHub. But you know, in principle, you can fork any project. You can create your own clone of any project on GitHub, and you can host that somewhere else, somewhere on GitLab or on your own private server. And that's, as far as Git is concerned, just as valid as the original version that is hosted on GitHub.
Or even you can fork off something that's locally hosted as well. So that
Yes.
even on your own drive, you have two projects where one is a fork of the other. If you wanted to compare two running at the same time.
So the point is, yes, you can fork pretty much anything in Git. So you can even have a fork of your own project on your own computer. That's perfectly valid as well. You probably would prefer branching in that case rather, but you know.
Just doing some kind of random performance test. That's the only use case that I have in my head for it. But like.
Yeah, another one is just making sure you've committed everything, right? Is a good. You can just check out another one locally and just make sure everything's in there, right? But yes, it's perfectly possible to do that. There's no central authority, is the point I'm trying to make. So Git is, as I say, it's taken over, and it's particularly suited to very large projects. As I say, it was originally designed for the Linux kernel, which has thousands of developers and tens of millions of lines of code, and it's really, really good at handling these things. So the way it works, I mean, it'd be a whole 2-hour thing by itself just to try and explain how Git works, and I surely couldn't do it, and because I'm really not an expert in how it works under the hood. I just know how to do bits and pieces. But basically, Git works by tracking your source files and tracking the changes you made to them, and tracking the changes that are introduced in every commit, and building those changes on top of each other. And because Git's distributed, as I say, our version of something is just as good as somebody else's. We can copy someone else's repository, clone that repository. We can do absolutely whatever we like to it on our own system. It's not going to affect anyone else. We can upload our changes wherever we like. Right? It's not going to affect anyone else. Eventually, probably if we're working on an open source project or we're doing something for work, eventually we're going to want to push those changes back to the people who own it, right? But hey, maybe you don't like those people and you want to start your own fork with new features that they won't accept or something like that. Well, you can do that with Git. And as most of you, I'm sure, know, GitHub in the last few years has sort of become the thing that Git was supposed to never supposed to have, which is this sort of de facto standard central authority for projects, which has positives and negatives. I mean, it really takes away a lot of the distributed goodness of Git. But on the other hand, the user interface for GitHub is really, really pretty good, and it automates a lot of things that are quite awkward to do on the command line. And it has very good integration for pull requests and has issues, and you can do things like git blame, and it's GitHub is really pretty good, I've got to say. So today we're going to be just having some practice using Git on the command line. Lots of you put your hands up when you said you'd already used Git, so you're probably going to have no problems today. Next week we'll have a bit of fun with some GitHub repos and cloning them and forking them and submitting pull requests and things like that. But for today, we're just going to focus on the command line. There are plenty of GUIs available for Git. There's even one that ships with it. I think it's called GitK, that looks like something from 1985. But almost every person I know who sort of does it for a living really prefers using the command line interface for Git, not because the CLI is particularly good, but just because it's a lot quicker and a lot faster once you're used to it. So that's sort of my aim for today, is to get everybody comfortable, at least doing the basics on the command line. So a quote from Linus, just because people pointed out that the word Git has a meaning in British slang. He was just saying, yes, I know. That word originally was not person, but you can fill it in with your word of choice. Okay, so does everyone have the command line version of Git installed on their computer?
Well, if you have Git, you must do.
Does anyone not have Git? Would you like to install Git so you can play along today?
Yeah, sure.
You can just go to git-scm.com and it has a big download button on the front page.
Oh, well, git-scm.com/download will take you there.
But you should have it in your context menu anyway. If you use a GUI browser operating system.
I think that's only true on Windows if you've used their official Windows installation. There are many ways of installing Git on Windows. But yes, I think the default installation adds a right-click command to say, open this directory with Git or something like that, doesn't it? Yeah. Yes, just a word of warning. I as you might maybe or may not be able to see, I do have a Mac and don't have Windows. So hopefully all of these commands will work just fine on Windows. If they don't, I apologize.
It's going to be fine.
It's going to be fine. Nothing we will do requires in any way a new version of Git.
Git 221, I'm not sure where you're getting that from.
No. His installed version. Yeah, that's
Oh,
trust me, that's plenty new enough, right? Basically, if you have anything, it doesn't matter if it's Git 1.0, it will still work for today. We're not doing anything remotely complicated.
Don't do anything case sensitive. Windows guys will be fine.
Anyone use Visual Studio now?
I'm using it now.
Or else? Did you install anything except like this add-on? Visual Studio?
Studio plugin will give you command line Git. So you should, just open the command prompt and try to open Git. Works, you get.
Easier for Windows PowerShell. Probably Windows Administrator if you do PowerShell.
So you definitely get it.
They're encouraging people to stop using that, the standard batch style of Windows, right?
Yeah.
Shell commands, sort of PowerShell.
Yeah. PowerShell is that big.
Or you can get
I'm not sure whether you can get
the Ubuntu Windows.
Yeah, you can't go to the command prompt in Windows. You have to do the only one that comes up is the PowerShell.
I typed in Git, it just told me the commands up and these would Git. So do I have Git then?
Yes. If you do git -- version, it will tell you your version number, and then if that works, then you're good to go.
You can also install it at home for if you are on Mac.
Yes, I thought I mentioned that. That's good because it will stay updated as well.
You know what homebrew is after on Mac.
Yeah. Come on. Okay, we're back. Has everybody managed to get Git installed? Is this git -- version or git.exe -- version? Is that working for everybody? All right, tell me if it's not. Otherwise, I'm just going to go on and you won't be able to play along for the rest of...
You don't need to put .exe on Windows.
You don't?
No, you don't.
Oh, well, okay, good.
It's the same. It's the same for Windows or Mac. Just type git. Don't type git.exe. Keep it simple.
Okay, let's have a play then. So, step one. We need to create a repository. Yeah, hang on. What's the repository? So, a repository, in Git terms, it's a directory. You initialize a directory as a Git repository. And once you do that, everything that lives in that directory, including in any subdirectories, that may be added to your repo. I'm going to use the term repo a lot, repository, right? So once you have initialized a repo in your directory, Git can never add anything outside of that repo, right? Outside of that directory, sorry. Right? It will only look within that tree. Yes. Either has to be directly in that or in a subdirectory of your root, of the root of your Git repo. So typically, every project will have its own Git repo. It will exist as its own thing on GitHub, say, or as its own repository on your computer or maybe on your works server. This is not universally the case. Google famously has one Git repository that has all their source code for everything. I mean, billions upon billions of lines of code. The whole thing's like 20 gigabytes or something. It's ridiculous. And somehow Git still works. So yeah, Google famously don't do the one repo per project, but almost everybody else does. And I definitely wouldn't recommend using Google's approach, unless you're Google.
I mean, Microsoft have said stuff that makes it sound like didn't they sort of like fork Git to kind of handle like partial pulls so that you could.
Yeah, I believe Microsoft have moved to using Git internally, and because again they've got thousands of developers all doing things at the same time, and they went for the Google approach of sort of one mega repository. Yeah. They had to make various changes to the Git source code to handle.
File systems, basically, that's what they kind of introduced.
Yeah, I've got to be honest. I don't know the details of the changes.
You don't have to take the whole root of that repo. You can pluck a portion of the repo.
Oh, okay.
Yeah.
So yes, the point was that Microsoft have a forked version of Git that.
Right, yeah. It was something along the lines of Git submodules, but clever optimization they think, which was mainline as well. It wasn't just something they kept just themselves. Google do have the massive mono repo, but they have a load of clever proprietary code to make that work.
Yeah.
Scalably.
Yeah, I guess the point is if you're working for one of these absolutely enormous companies, Google or Microsoft or maybe Facebook or Apple or whatever, they can do their things in their own weird way. We just want to keep things simple, right? One project, one repository, easy. So the way we initialize a repository is really simple. We change on our command line, we change into that directory, and we run git init. Init for initialize, git init. We'll create a repository, turn that directory into a Git repository.
Nothing in it.
With nothing in it. So let's have a go at that. We're going to create a new directory called git exercise. mkdir, git exercise. Oh, that formatting hasn't worked very well. But anyway, cd git exercise to change to the new directory. And then you can run just git init. And it will hopefully tell you it has initialized an empty Git repository.
Is there anyone here who's not comfortable at all with the command line because you don't really want to be doing this in a random folder because you'll never find it ever again?
That is true.
Anyone who's not comfortable with the command line? No? Cool. Okay, everyone knows the command line. Great.
This is going to be a much easier session than I thought it was going to be.
Everyone, yeah.
Yeah, no, this is awesome.
To make a directory, CD.
No, that's the change directory.
Yeah, CD is change directory. MKDIR. Make directory. MKDIR.
I think MD works on Windows as well.
Probably, yeah.
Does it? I know MKDIR works. It used to work on DOS anyway. Don't know whether it still works on Windows. Yeah.
Unlike LS.
You can get Git bash, and then you've got a few command
Yeah. Yeah.
Can you modify it on ls command so that it shows you also the hidden files?
Sorry, I didn't hear you.
When you want to list all your files in a directory,
Mm.
and I mean there should be
Yeah.
a Git file, shouldn't it?
Yeah, ls-a.
Ah. Okay.
Oh. So yes, Michael pointed out that when you do this, if you then, on Unix systems at least, if you just run ls, look at the contents of your directory, it's empty, right? Nothing's happened. But actually, what's happened is Git has installed, or Git has written a hidden directory called .git, a hidden subdirectory, and inside that is all the information that Git needs to manage the repo, right? So if you do ls space -a, then you will see this .git subfolder. So, anyone not there? 3, 2, 1. Excellent. Let's just have a look at that. There we are. Initialize an empty Git repository in that directory. And you can see it even mentions the hidden .git folder. Do ls. There's nothing there. If we list all, we can see we've got this hidden .git folder. Getting the status. So I would say pretty much the most useful command in the entire huge pantheon of Git commands is git status, which you can run at any time from your directory, and it will tell you the current status of Git. It will tell you what branch you're on. It will tell you what file changes it can see. It will tell you about files that it can see but aren't being tracked. It will tell you if you're in the middle of a merge or a rebase or any of these complicated things. It will tell you if there are any conflicts. Git status, I mean, it's probably the most useful command there is. Just try it now. You can run git status. As I say, anytime you're inside a Git repository, you can just run git status and it will tell you about its current.
I don't want to get ahead of you. You're going to go into the difference between tracked, untracked, and staying.
Yes.
Stash. Good one.
Sorry?
Stash.
I'm not going to talk about git stash today, no. So at the moment we've got an empty directory, an empty repo. That's not much use, right? You're not going to get many people giving you stars on GitHub for an empty repository.
That's the goal.
Sorry?
That's the ultimate goal.
That is the goal. That's why people write open source software, right? Stars on GitHub. That's sweet, sweet internet points. Anyway.
Smash that like button.
Yeah. Let's have a go. Let's have a go at actually adding something to our repository. Let's create a file called hello.txt. And we're going to just add the text hello to this text and save it in our Git exercise directory.
You do it in Windows Explorer, you don't have to do it because it's not one.
On Unix, I just do Vim, but I don't know.
Right, if you're on Windows, just use create a
Notepad or something, yeah. And save it into that directory.
Visual Studio Code or whatever you like.
It doesn't make a difference because when you use the bash interface, it uses the Linux commands.
If you're using Git bash, you can use it as if it's Linux based. It's still case insensitive. You can put it echo. I would suggest use whatever you normally use if you were writing code, because this is how you're going to do it anyway in real life.
Yeah, you won't be writing text files. You'll be writing C++ files, right? Because that's the language we're going to use from now on. But just to avoid dealing with any C++ today, we're just going to use text files. So if you do this and you save the file, what happens if you then run git status? Can anybody tell me?
What colours do you see? What does it say about the file?
It's unstaged.
You said on track?
Untracked file, absolutely. So Git, it notices that there's this new file called hello.txt sitting in your repo directory, but it doesn't know about it yet, right? You haven't told it that you want this hello.txt to become part of the repo. It will tell you it's untracked. Right? So we can see we've got this now got this file hello, just says hello. And then if we do git status, tell us we haven't made any commits to our repository yet, but we've got this untracked file called hello.txt. And it suggested that we can use git add file. So try it, do it now. Run git add hello.txt. And yet again, run git status, because as I say, it's such a useful command. It tells you exactly what Git's thinking right now, so you don't have to guess. You'll see the file is listed as a change to be committed. In fact, it will say new file next to it. Oh no, the run is not part of the command. Sorry, the font was supposed to make that clear. It's just git add hello.txt. Yes, git is the root, and then you say git command arguments. That's the format of all the commands. Yes. So having done this, having run git add on our file, our changed file, in this case the change was creating the file in the first place. Having run git add, we have staged the change in the terminology. It means that we've told Git that we want this change to be part of our next commit. But it hasn't been committed yet. It's not yet part of our repository. It's a staged change. Yes?
Well, what would happen if you modify now after this, after add, the hello text? Is that okay or bad?
Then you would have to add it again to say, no, hang on, I want you to update these for these other changes.
So the Git would keep like separate copies?
Almost, yes, effectively. So we can stage this file. We can say, I want this file to, in a minute, become part of the repository. And if we make a mistake, we can unstage things again. Right. Git rm or git reset, they're commands you have to be a bit careful with, but actually git status will, in fact, tell you how to correctly unstage something if you made a mistake. The other thing we can do, it's really awkward to do on the command line, but it's quite easy from GUIs, is we can stage some changes. If we've made many, many changes to a file, but we only want some of those changes to become part of a commit, it's possible to stage just some changes we've made to a file. It's a pretty niche thing, but it's nice that it's possible. So just for the benefit of people watching along, we can run git add hello.txt. And then git status again tells us we've got no commits, but we have this one change ready to be committed. And we can unstage our changes by running that git rm command. You have to be careful with git rm, but if you run the -- cached, the other one is to, that I personally use is to say git reset and then file name.
So what does it do exactly? Git reset?
Git reset will remove that file from staging. Okay, if you run git reset -- hard, then that's the really dangerous one, right? That will destroy your changes.
Git reset resets the commit you're on to whatever you tell it to reset to. It won't, by default, touch the file system. It will not physically delete any files. What git reset actually does is it points you at a commit. You could rewind 10 commits into the past. By default, it's head, exactly. It is the commit you're already on. So by default, if you have no changes staged, you have nothing to do, git reset effectively does nothing.
So we've now staged our changes. We've prepared our change set. In this case, we've only got one change. We're adding a new file. But in principle, and usually when you do this, you'll have many, many files that you've changed. So to make these permanent, we need to commit these changes to the repository. Now, as I say, usually we'll have changes to many files. In this case, it's only one. But I don't want people to think that you can only change one file at a time. That's not the case. You can add many changes from many files to a single commit. When we create a commit, when we add these changes permanently to our repository, Git requires us to add a commit message. Right? And a commit message, the point of it is to tell other developers what we changed and why. So the commit message should have a short summary of what you changed at the beginning, right? In the first line. A short summary of what you changed. I think GitHub limits you to about 60 characters. 72 characters, I think it is, right? So we're talking a few words, right? After that, so put that on a line by itself. After that, if you need to go into more detail, then by all means, you can write a longer, more in-depth message.
I always say that obviously you always have the one line, you have then followed by an empty line, and then perhaps multiple paragraphs, proportional to the amount of code you wrote. If you change several hundred lines, write 2 paragraphs to explain it. If you wrote a few lines, probably a sentence is enough.
Yeah.
It's a good idea to put runs. It's a good idea to put runs. I'm fixing this bug because the other one I didn't fix it.
In case the microphone can pick it up.
Yes, Tom's suggesting that you put rants in commit messages, which is probably not.
I meant before what Tom said was.
Yes, so you should have a short summary on one line, then leave a blank line, and then if you want to, if it's a large change or there's something that is perhaps not obvious when you first look at it, and somebody might look at those changes and go, well, why on earth do you do that? Then you can go into more detail in the commit message, in the body of the commit message. But the summary, the first line, should be a short summary. And the sort of corollary to that is if you cannot summarize the change in a single line, in a few words, well, perhaps you're trying to do too much in a single commit. Right? As I said, it's possible to do a big load of changes and selectively choose which of those changes go into a single commit. A sequence of commits should almost tell a story, in a way, about how you're changing the code. First I'm doing this, then this, then this, then this.
So the idea is when you're doing your version control, that you have a specific thing you want to do. You don't wait to do a million things then, right? You do it as you go, yeah?
Well, we're going to talk about branches in a moment.
But I think the point is you don't just make one big commit at the end when you think, oh, I'm done. You can kind of use commits to mark progress. So
Yeah.
that as you're developing, that way, if you go, oh shit, I've kind of gone wrong, you can rewind more easily if you just kind of commit quite often to an extent. And
Squash it later.
squash it later.
Yes,
Yeah.
yes. If you write many small commits as you're going along, as I said, it becomes easier to backtrack if you find you've made a mistake. Right? It becomes easier to an extent to follow your sort of train of thought, how you got to where you did, rather than just, going from A to B and, how on earth, why is this? There's been 10 million changes and this is really hard to follow.
Sometimes you probably don't know why you did what you did.
Sometimes you don't know why you did what you did.
Because there's
Well,
no progression. Like, why did I do that? And why did I do this? You have to basically go through, oh, okay, I see. Rather than having it right at the beginning, okay, I did this because that. Sometimes you look at your code, why did I make that decision to do that? Why didn't I do something else? So you can say, as you're looking at your commits, you can say, okay, I did this because that. So it's quite logical in what you're doing rather than doing loads of things. Why the hell did I do that? Because you can't tell me every time you look at your code to remember what you did.
No,
Yeah.
but the thing is, you don't want to keep those commits forever. So you do this thing where you squash when you merge into a branch, and you've got to then use the technique of self-documenting code. So there's like the method name that like explicitly, for example, is as meaningful as possible, and then you have to resort to comments if it's like, oh, this is because it's a workaround because of a weird bug in the runtime I'm in or whatever. Like,
so the microphone probably didn't pick that up. There's a bit of debate about like how frequently to commit and how making frequent commits can help you if you're the one looking at your code 6 months later going, well, why on earth did I do that? If you can see the train of changes that got you there, then you're a lot less mystified as to why you're suddenly doing this. Now, there is a flip side to that is if you're just having lots of commits with tiny, trivial changes, right, then that gets really tiresome for someone else to read. So there's a balance to be struck, right? You don't want to commit thousands of lines of changes in one go because that's going to be impossible, if for nothing else, impossible for anyone else to code review. But in the other extreme, you don't want a sequence of one-line changes. That's too far in the other direction. There's a balance to be struck. One of the things Git lets you do, we're not going to talk about it today, but one of the things Git lets you do is when you have your own private branch, you can effectively rewrite history and squish commits together and change commit messages and reorder commits and things to turn things into a logical sequence that is easy for someone else to follow.
Would you also stop with a commit if you're saying you're not sure how you're going to code something a little bit, and you're going to try something that you're not sure is going to work? So you could, if that one doesn't work, you can go back and then start on another track, shall we say, to...
Yeah, you can revert commit.
Yes. So,
So you can do a test commit or a test code.
so
Swap another.
John's question, I guess, or point is that you can use these to effectively experiment, to try something out, to say,
Branches.
is this going to lead to a solution, or am I just getting myself deeper into trouble? And as we're going to talk about in just a couple of minutes, Git allows you to create different branches that don't affect each other in that way. So that's probably the killer feature of Git, is this cheap branching. Sorry?
Kind of, is that the idea of like forking in like Unix or whatnot?
Yeah, kind of. Yeah, kind of like forking a process in Unix, I suppose. Except that you can't then merge those processes later, which you can with Git.
Branches are pointers.
Anyway, back to talking about our commands. If we want to commit something, we can use git commit. Don't do this just yet. If you do, Git's going to launch into a text editor because, as I say, it needs a commit message. You can't have a commit without a commit message. Doesn't matter if you can have a single space if you want. It's not very useful. But you can't have a commit with no message. So if you just run bare git commit, Git will, all of your staged changes, everything that you did git add, Git will summarize those. It will list all those, in the sort of draft commit message, and you can then fill in your message saying what you changed. So that will launch your system default text editor. I'm not actually sure what it does in Windows. Probably whatever handles txt files. On Unix, it will use whatever editor is defined as, which I think defaults to Vim. Possibly Nano, depending on your distribution. If it's Vim, then good luck exiting it. There is a shortcut. If you have just a really trivial change, you can do git commit -m, and then write your message in. Those should not be curly commas. That's Keynote trying to be helpful. They should be just straight quotes. Just write git commit -m.
Please don't, unless it's really,
Unless it's a really trivial change, right? So if you do this, this is effectively good for something where you only need the one-line summary. In this case, well, we're not doing anything very complicated. So the one-line summary is probably fine for us. We can write git commit -m, and again, I'm sorry, those should just be straight quotes. Don't worry about trying to add Unicode, right? Just added hello.txt. So try that command now, git commit -m. To commit our stage changes, you should have hello.txt staged right now. Let's just have a quick look at what that looks like. So we can see it's added hello.txt. There was one file changed, one insertion, and it's created a new file with those Unix permissions, if you know what that means. Called hello.txt.
it's read, write, owner, read group, read everyone else.
Yes. And then if we run git status again, we can see we've got nothing to commit. Right, there have been no changes since our last commit. A working tree, as it calls it, is clean. That is, there are no differences since our last commit.
And most importantly, you now have your Genesis commit, as it's called. The very first commit in the repository.
Yes, although not really relevant today, but yes.
The Genesis commit is slightly special. It has no parent.
Do you know the shortcut how to exit this text editor?
So for those who don't know, there's a sort
It's in Vim.
a sort of meme on the internet about how nobody can quit Vim because it's really obscure. Control-Alt-Delete, yeah, no. Delete Vim, yeah. Yeah, escape colon Q or WQ.
Then you can have exclamation mark if you want to cancel any changes you make to the file. Just like you did. If you did the Q, you say, sorry, you made changes.
Vim is fantastic.
It is fantastic.
The thing to learn about Vim is it has two modes. You have an insert mode, well, there's a replacement. You have a mode where you're actually editing the file. You have a separate mode where you're just manipulating parts of the file, where you're commanding the editor. That's why it's confusing for people. Once you learn it, it's incredibly efficient. Anyway, I'm interrupting. Carry on.
Okay, that probably wasn't picked up, but it was some Vim propaganda. I'd say, Emacs forever, but I don't even like Emacs, so yeah. Emacs. Vim does sound like a cleaning fluid, yeah, absolutely. A cheeky Vim toe. No. Right, viewing history. Let's get back to talking about Git, shall we? It keeps a history. In fact, it keeps a history of pretty much everything you've ever done. But we're not going to delve that far into it today. We're going to look at the basic history of the changes that you have committed to a repository. And it's really easy to do. We can run git log. There are all sorts of arguments you can give to git log to, view commits between certain dates, or view commits in reverse order, or view commits starting somewhere and ending somewhere else. There are tons of different arguments you can give to this, but the most basic one is git log. That will show you all the commits starting from the most recent and going back in time. So you could just give that a try and tell me what it says. I'm sorry? All right. So if you do this, you should see, because we've only got one commit to our repository, you should see the author, the timestamp, the commit message, right? All the useful information. And if we had more commits, you'd see all of those listed as well. There's also this long, weird sequence of sort of random-looking characters. You might notice that. That's something called the commit hash. It's, I think it's SHA-1, or was it MD5?
SHA-1.
SHA-1 hash of all the changes that commit introduced. It's not something that you really need to worry about very often, but it's a way of uniquely identifying that commit. And the chances of ever having a commit, two commits with the same hash is incredibly remote, unless you're specifically going out of your way to try and be awkward.
Is everyone clear on what a hash is? That sounds like a no from the side.
It doesn't really matter what a hash is. Just take it that this is like a unique identifier for that.
Digest all the data down into a unique identifier. Yeah.
let's take it that this is like a unique identifier for this commit, right? And occasionally when we're doing other things, we need to refer to a specific commit, to a specific position in a specific branch at a specific time. Then we can use this hideously long identifier to do that. Fortunately, we don't have to use the entire 64 characters of it. We just need to use enough of it to uniquely identify it within our repository, which probably if you just copy and paste the first 4 or 5 characters, that's going to be plenty, right? Will it autocomplete?
Like with a tab?
No, but I mean, it doesn't. It might, but it doesn't need to, right? You just copy and paste the first. So if you're doing something like a cherry pick, which is where you grab a commit from one branch and just paste directly those changes into another branch, you might do that using this commit ID, this hash. But again, it's not something you have to worry about for most uses. But if you're wondering what it was, what it means, why it's there, it identifies the commit uniquely. Oh yes, better just show that one for the people who are watching along. So if we're on git log, you can see in this case the commit hash is CB37 blah 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 blah. And we got one commit. It was by me. It was made this evening. And the commit message was hello, added hello.txt. So now that we have a file in our repository, we can start using Git to track changes to it. So if we edit our file, hello.txt, so that it now says hello Git instead of just hello. If we do that and we save our changes, Git's pretty smart, and it's going to notice that the file's changed. And if we look at what Git is thinking, if we run git status, Git will tell you, I'm tracking this file, and you've modified it.
Can you have a whole folder structure in this?
Absolutely, yes. Can you have a full folder structure within a Git repository?
Yeah.
Absolutely. No, you're very much encouraged to do that, yes.
So even if you run git status, it will go through the whole
Git
tree
status
and all
will, yes, will list all the changes in all the subdirectories. If you run git status from within a subdirectory, it will only tell you about the changes from that subdirectory down, if you see what I mean.
Commit from it. You should try to commit from a subdirectory.
It will work just fine. Did that come out on the microphone? Anyway.
It did.
So Git notices that the file has been modified. And again, we can stage our changes by saying git add hello.txt. We can say, OK, I want you to take the changes I made to this file and make them part of the next commit. If we do that, we stage our changes. We can use the same command, git commit, and in this case, save the bother of launching the text editor. Just going to do git commit -m, edit hello.txt. I hope it goes without saying that your commit messages should usually be a little more descriptive than that. This is just for practice purposes, right? Just edit file is not a very good commit message. No, that's not going to help anybody who's browsing the commit history to find out where a change was introduced, right? But it's just an example. So we change the file, Git will notice we've made changes. We stage those changes. We might stage more changes from more files, and then we'll commit all those changes in one go. And now, if you do this, if you've added this second commit, if we run git log again, we'll see now that our history has 2 commits in it, listed by default in order from most recent, going back in time. So just for the benefit of anyone who might be watching, I'll show you what that looks like. So now you can see it's telling us we've modified hello.txt, but that change is not staged for commit. And you notice it's actually given us a recommendation for a shortcut at the bottom, git commit -a. If you do this, that will automatically include all of the changes to existing tracked files that it knows about. Right? Git commit -a, that's like git commit all.
I believe there is a subtle difference, which is that if you deleted files, git commit, no, sorry, I was thinking of git add -u, never mind. Ignore me.
Okay. So git commit -a is like a shortcut, is git commit -all. Right, so it commits all your modified files. Git commit -a will not add new files for you. You still have to manually do git add when you add a new file. Right, but in this case, we're not adding any new files, so we're going to use this shortcut. And we can mix it with -m as well. So git commit -a will, everything that says modified next to it, it will add those commits.
So I'll add those to my thoughts now. What I meant to say was that I generally prefer to avoid doing this git commit -a. It's generally sort of better and more organised to use git add -u. Then you can run git status to make sure it's
yes.
the state that you like.
Yeah.
Before you just go and commit it. If you use git commit -a, it's just going to throw the commit straight in there. It's not a big deal. You can reverse the commit technically, but it's probably better just to be organised, more organised about committing code. Yeah.
So git commit is a shortcut, but it's a shortcut that you perhaps shouldn't use recklessly. Doing it in 2 steps, git add followed by git commit, lets you run git status in the middle. Make sure you've added all the things, added the right things. You're not, committing a file that shouldn't be committed, that kind of thing. So you can see we've added a second commit. We've run git status again, and it's saying nothing to commit now because we've committed all our changes. And we run git log again, and we've now got 2 commits. Added hello.txt, and more recently, edit hello.txt. So, branching. I'd say an important feature of Git. Probably the absolute killer feature of Git, the thing that it's most useful for, is this idea of branching. Talked a bit about old version control systems from the past. They did have notions of branches, sort of, Subversion did, but they were really heavyweight things that kept a copy of the entire history, and creating new branches was really awkward and horrible. With Git, branching is super cheap, right? As in, it's very fast. It's very fast. It doesn't store anything basically other than a tiny little reference to the parent commit. It's free, effectively. Right? Branching costs you nothing. And branching is great because it allows us to create a new parallel version of history, starting at the place we branched off from, right? So it's a bit like Back to the Future 2, when they went back in time and they found out that Biff Tannen had gone back and forked it. Nobody's seen Back to the Future 2, have you? Everyone's looking at me like I'm mad. Anyway, go and watch it.
No, we'll just keep it quiet.
Okay, right, yeah. At some point in the past, the timeline split, and now you've got two parallel timelines, and that's what branching does. Unlike Back to the Future 2, though, Git allows us to merge branches back again. So in particular, what this is usually used for is that we will have our default branch, which is called the master branch. You might have noticed on these Git logs or Git status, it tells us we're on the master branch, because when we did git init, that was the default branch name. And what we will usually do, the usual workflow, is that you want to add a new feature, or perhaps you want to fix a particular bug, or whatever set of changes it is you want to do to this project. You'll create a new branch for those changes from master. And then you will go away and you'll write your sequence of commits that implement this feature or fix this bug or whatever it may be. And when you're happy with them, when you're happy with these features, you can merge these back, if you like, into your local master, which is just on your computer. Yeah?
Sorry, if you own, like, say if I go to Git and I look at John's repository, I actually did this last weekend actually. If I do, say I have my own repository.
Yeah.
And you look at my repository, you can branch off and go in a different direction. Is that possible?
Yes.
And then, me being the head of that, could I then commit that? If I thought that was D, can I commit that to my repository?
Yes, you can commit it to your own local repository, right? And what you can do then is to say to John, hey, I've made these changes. Why don't you have a look at them and see whether you like them, and see whether you want to include these changes in your version of the project. Right. Now, we said Git's a distributed version control system. So your version of the project is, as far as Git is concerned, it's just as valid, it's just as authoritative, just as central as John's version. But perhaps John wrote the software in the first place. Perhaps everybody else on the internet looks to John's version because that was the official version. So yes, question.
I figured when you're trying to merge back into the main branch, it does prioritize the version that is already present in the origin branch. I mean, usually if you have a merge conflict, it will come back to you, and you would have to change your version first before you can merge it back.
Go on.
Actually, Git doesn't care. So Git firstly has the concept of creating a branch and helping you by allowing you to say, oh, my upstream branch is, say, master. But that's just Git helping you. Git doesn't care. The usual flow, though, is that yes, it's generally expected to be your responsibility that you'll fix your conflicts to go into the main branch. But Git doesn't actually have a concept of a main branch. Just as equally, you could go and make the main branch fit your work, right, your feature branch, but that's generally obviously not how you would do it. But Git itself does not care. It's just helping you by giving you that. You could do it the other way around if you wanted to. So.
But you got to set masters.
Say that again.
You got to set them, otherwise you just.
You have to set. You must set the upstream branch when you. Well, you don't have to. You can have a branch with no upstream. But generally speaking, when you are on master and you check out -b to some other branch, because you were on branch A, which is master, it's going to automatically set that for you. So it means it's going to just track it and say, oh, this is the upstream. It's just helping you out, but it doesn't actually care.
So I'm just thinking in terms of, like, say we had something with virtual functions in it, yeah? So we like made some kind of API of virtual functions. I could say to you, you can go away and make an implementation based on whatever. And I could look at your implementation, and could I then say, that's good stuff, I'm gonna commit that to my repo.
Yes, absolutely you can, yeah. So we're running short on time, all my fault for, you know, being late. Apologies again. But let's have a very quick look at the commands we'd use for branching. So the first thing we do is to create a new branch. There are a couple of ways of doing this. This one's the easiest. We run git checkout -b. So git checkout is the command that's used to change to a different branch, amongst other things. Checkout is not like, hey, check out this code. It's terminology that actually comes from older VCSs. But we check out a particular branch. We change to a particular branch using git checkout. But if we use this -b flag, then that changes it to a mode that creates a new branch for us. So we run git checkout -b and then our branch name. For example, our little example, we run git checkout -b goodbye. And if we do this, Git will helpfully tell us it has switched to a new branch, it's created this new branch goodbye, and it's switched its attention to our new branch. So anything we do now, any commits we make, anything we stage, whatever we do, it will affect our new branch, right? We no longer care about master branch, at least till we switch back to it. So anything we do to our new branch won't affect master.
To give maybe a relatable parallel, you've switched to a separate reality. So you can now enjoy this separate timeline without affecting any other timeline or reality, as it were.
Exactly that, yes. So if we use the command git branch, again, this is something that has lots of flags, that has lots of different behavior, but the default, just writing git branch, it will give you a list of all the branches that it knows about. And one of those will have a little star next to it. Well, unless you're in funny situations, but most of the time one of those will have a little star next to it, and that will tell you which branch you're currently working on. And as you might already have seen, git status, this wonderful command for seeing what Git is thinking about. If we're on git status, it will also tell us which branch we're on. Let's just do that very quickly. Go away. So we're going to git checkout -b, and then we'll run goodbye. Oh. So here we've switched to a new branch goodbye. If we run git branch, you'll see we've now got two branches. One of them is called goodbye, the other one's called master. And again, we can run git status, and it will tell us we're on branch goodbye. We've got nothing to commit, we haven't changed anything yet, but we're on this new branch.
So what happens if we go and change hello text now?
That's a very good question, John. What happens if we go and change something now? Well, instead of changing existing text, the existing text, let's add a new feature to our program. Let's add a new file named goodbye.txt, containing the text goodbye git. And having done that, we can do as we do before. It's a new file, so we always need to say we need to say git add. We need to say I want you to track this file for me, please. And then we commit those changes. And having done that, we can, as before, use git log just to see that we've got this new third commit added to our history. So I'll just do that very quickly. So now we've got this new file, goodbye.txt. So we add that. Look at the status again. We've now got one new file. Again, we'll just use a short commit message. And we'll see that it's created this new file, added it to our repository. Now if we look at the log, we've now got 3 commits. And if you look very carefully on your Git log, it will actually tell you where we forked off from master. It will say that the master branch status is still at this 2nd commit. But we've now moved to this 3rd one.
Best feature of Git is that you can always fork off.
Thank you very much. So one of the brilliant thing is these branches are absolutely independent of one another. We have modified our goodbye branch. We've made changes to it. We've added a new file to it. In fact, we could have changed anything. You know, we could have deleted hello.txt. We could have overwritten it with something else. We could have done whatever we wanted. And we wouldn't have affected master. And provided we've committed everything, we don't have sort of files that would otherwise, changes that would otherwise be overwritten, we can switch branches at any time we like. So we can try it now. We can run git checkout master. And that will switch from our current branch, which was goodbye, back to the master branch. So if we do that, and if we do this and we list the directory, we'll see, goodbye.txt has disappeared. And if we run git log, our new commit has disappeared. Oh no. But don't worry, everything is safely still there. We've committed it. We've committed these things to Git in a different branch, but they're still there. And Git never forgets anything. Well, unless you tell it to, and even then it tries really hard to remember. It's still there. All we need to do is switch back to our goodbye branch with git checkout goodbye, and then you can do ls or dir, and you'll see goodbye.txt has reappeared.
It just disappeared, reappeared, file explorers.
There you are. And again, if you switch back to this other branch, you do git log, you'll see the new commit message, the new commit there as well. So we can work on these changes. We can split off the timeline into 2 parallel branches, master and our feature branch. Right. But at some point, we're happy with our changes. We want to merge them back again. So we want to merge them back into our local master branch. So first of all, we have to switch back to the master branch, if you've already done that. If you haven't already done that, if you changed to goodbye, just use git checkout to change back to master. And then we can say git merge goodbye to say take all the changes from the goodbye branch and merge them back into this branch. Merge the 2 histories. You're going to say something?
So, if you understand this, great. If you don't, then ignore it. There's 2 kinds of merge. There is a true merge, where 2 two divergent histories, if you imagine two things going parallel, maybe your teammate did some work and you did some work, and you do a merge, and that results in what's called a merge commit, which has his work as one parent and your work as another parent. If, however, you do a merge and actually no other work was done, you just did an additional commit on top of the existing history, which is what you did just now. That is called a fast forward. And I believe it will tell you that it was a fast forward when you run the command, because there was no actual divergence to rectify. So it just says, oh well, there was nothing to rectify, just go here, go to this future state.
Yes. So in this case, this merging was very simple. And the reason it was simple is because the master branch hadn't changed from the point that we diverged from it. Well, that's probably not realistically going to happen when more than one person's working on a project, right? Usually, you create a branch, you work on something, maybe you hack on it for a week. In the week, you merge your changes back because you're happy with everything. Maybe somebody else has come along in the meantime and merged their changes. So in that case, as Ollie said, Git will do something a bit more complicated. It will do something called a merge commit that will tell you what the parents were.
And you can forcibly create a merge commit if you wish, even if it would be a fast forward. It still only has one parent, but it will explicitly generate one that says, oh, by the way, this is a merge.
Which I think is what GitHub does.
Which is what GitHub and GitLab and many others do.
Yes. Things can get a bit tricky, though. Because if master has been chugging along and being updated, and somebody has changed a file that you've been working on in a way that is incompatible with your changes, Git's gonna get a bit testy with you, right? It's not going to like this very much. Now, actually, it is really, really smart. If you have two sets of changes in the same file, that's fine, unless they're touching the exact same lines of code, right? The algorithm Git uses to do the merges are really smart. So it only really happens if two people have altered the exact same lines of code in the same file, right? But in that case, we're going to have something called a merge conflict. Git's going to say, look, I can't bring these two pieces of history together in any way that makes sense. Yes, Tom?
What if one of the, let's say you made some changes and somebody else, and your changes actually affect each other? What's happening in such situation? Git doesn't care, I understand, but how do you untangle the problem?
Well, this is going to be a problem because the first one to merge to masters, it's going to be fine. The second one is going to try and merge and find, hang on, I've got a load of conflicts. And then they go and march over to the other person's desk and say, what the hell were you doing? I thought I was working on this. Kind of. That happens. You know, in general, you probably want your teams to be a little bit better organized so that you're not fighting over the same thing. It can happen accidentally, and in those cases, it's really very easy to solve. Maybe someone's, you know, changed the name of some variables or something, changed things in a minor way, and that when you have this merge commit, Git will, sorry.
It's very common when you have multiple team members working on separate features with a similar overlap in necessary parts of the code that need to be changed, and it's not really anyone's fault there. And the realistic answer is that whoever gets theirs in first is the winner. And then whoever was slower now has to go and fix his merge conflict before it can go in. That is ultimately how it ends up happening. If you're quicker, you win. If you're slower, go fix the conflict.
I knew a guy that was using restarter. I knew a guy that was using restarter.
Resharper. Yeah.
He was really freaked because of this reason. He was quicker than everybody else, but everybody else was getting pretty much messed up.
So the bottom line is, if you're really quick, it's great for you, but everyone in your team will quickly hate you for all the merge conflicts. Makes sense.
So it must be possible to have code that's conflict. It must be surely possible to have code that conflicting that Git doesn't notice.
Yeah, merge conflicts. Fun.
How do you mean the Git doesn't notice? You can certainly
The internal logic of your program is the two changes don't actually go together, but you don't actually change.
Oh,
the
I see.
same
I see what
line
you
of
mean.
your
Git
code.
only operates on text, and it might be possible that it merges things in such a way that you're.
To comprehend the flow.
Yeah, it's no longer valid C++ or something like that.
To answer this question, and this is also why we're not just teaching Git, is that this is why you have continuous integration, because yes, it does happen. It's surprisingly not that common, but the whole reason you have CI in a pipeline is because when someone does make a change, and Git thinks everything's fine, but your code either doesn't compile or does compile, but actually is now horribly broken and doesn't physically do what you want it to, your CI, your continuous integration system, captures it because it builds the code. In the best case, it just fails to compile, great. Then maybe it builds the code, but it fails all your tests, right? So that's why you have CI for this precise reason.
So then you go back and take it apart.
So maybe that will happen, but I thought the whole point of this is like I'm always thinking like rollbacks and commits like that. So the whole point would be even if that was really bad for your code, you just go back to the old version, couldn't you? And then work back from there.
So usually you don't care about sort of going back per se, you just want to fix it because you have the features to release. The point is that your continuous integration system caught the problem. It's not gone to production, the customers haven't seen it, no one knows that problem exists because it's not really a problem. You know the failure's there and you just need to go and fix it and you make it work. And then finally it makes its way into the production build, the production branch, if you like, of Git.
It's not a problem, it's a challenge.
And the problem is a challenge, yeah.
Could it ever possibly be so broken that you're like, you know what, forget what you've done, let's go back to where we were before?
If you're incompetent, sure.
Okay, so yeah, fine.
If you're incompetent, and it's like, yeah, this is so broken, your code is garbage, go away. That's possible, but hopefully not likely.
So even when you were talking, when you have like, I think like we say with Google and stuff, you have loads of developers or loads of programs working. Like, I don't know, say you have a really large piece of complex software, you have loads of people working on like different areas of things. I thought the conflicts would be large, but you're saying it's surprisingly not that many.
Google is a unique case. Even though they have a mono repo, they break that repo down in terms of individual developers. They break down their teams into components. So even though, yes, you can clone their entire code base into this huge morass of all these individual parts, they're all physically segregated, really. It's not truly one application.
But they might have like common libraries that are internal that they might update.
Yes, Google do have common libraries, for example, that are shared between teams.
That's where the
But
risk is.
similarly, they have this concept of ownership, right? There's still set people who own those. Not anyone can just go in and say, oh, I'm going to change the code in a library. You must be a part of the team and have the permissions to do it.
I read an article that like was talking about someone who was from their experience, their anecdotal experience of getting access as quite a junior developer to quite a lot more than they imagined that they would have access to those. Yeah.
All right, so just to summarize, how do we use Git? What do we do? We fork, or we clone, or we create a new branch. Oh, sorry, we create a new repo. This is local, this is private to you, right? Maybe you've cloned it from GitHub or something like that. We create a branch for our feature, our bug fix. By the way, this workflow works just as well for your own projects on your own computers that you might be working on. Right? You create a branch. We add commits. Sequence of commits. As I say, we'll try and tell the story of how we got from point A to point B. And yes, once you get very comfortable and familiar with this, you can do things like go back and edit the commits from your private branch, maybe reorder them or do whatever, change commit messages, that sort of thing. Once we're happy, we can merge these changes. Now, if it's our own internal project, we'll just happily merge it onto our own master branch and carry on. If, as is more likely, we've cloned some open source software and we want to try and push those changes back, or perhaps we're at work and We need to commit our changes so our manager can see that we've done something. Then we have to push those changes to the upstream project, or in GitHub terminology, we'd send a pull request. We'd say, hey, we've made these changes. What do you think of them? And it's this last stage, this pull request stage, that's where the code reviews are going to happen. Right, this is where other people are going to look at your commits and say, why did you do this? Or, you know, hey, that's really good. Oh, you're a genius, right? Which is obviously what they always said to me. Wow, you're brilliant. No. Perhaps it's something we ought to cover in our core developer skills is code reviews. It can be a bit disheartening sometimes. You have, you know, one of your colleagues comes and points out something really stupid that you've done and you just cringe because you think, oh, I don't notice that. Or, you know, you can be really unlucky and have somebody quite unpleasant doing a code review and then they make you feel really bad. But yeah, for the most part, you should try and, it's hard, and I know this, but you should try and look at code reviews as a positive thing. You know, it's learning, it's someone else looking at your code and you know, telling you how you can do it better in many cases.
Yeah, I'm going to add to that once we get to hello. Yeah, cool. Yeah, just to really add to that is, yes, code reviews can be brutal. I would certainly say in the workplace, it's not reasonable if your colleagues are being horrible to you. Yeah. That's one thing. If you're contributing to open source, then yeah, you're just going to get brutality. Really. It's just going to be absolutely merciless, and just don't take it personally.
Yeah.
Treat that as a learning experience, but certainly in the workplace, people should at least be nice to you there, unless you've done something really bad.
Should we try and be constructive at the very least?
Constructive.
Constructive,
Yeah,
yes, not destructive. Constructive,
Yes.
yeah. Try. If you're in a position to do code reviews, yes, don't just tear somebody down. Even if internally you are thinking, oh, God, this is rubbish. Try and be constructive, right? Try and be nice.
Linus no longer is part of the Linux project or something.
Oh, he just promised to be a bit nicer.
Linus promised to be nice now.
Yeah.
I thought it was kind of like,
Which is the entertainment factor's gone now. It's a shame.
Yeah.
I mean, it's not really.
we're going to just do some gardening for a couple of years or something.
Anyway, we're way over time. So perhaps we'll talk a bit more about Linus's gardening. Not a euphemism. In the bar. But for now, thank you everybody for coming along. Thank you everybody for watching online. Again, apologies for dragging this on way past our designated hour. But thank you very much, and I hope to see you next week when we will talk. We'll talk a bit more about GitHub in particular, and then we might go on to talk a bit about CMake as well. So thank you very much.